Hello, in this video I'm going to be going over my latest project which I've completed now, which is called Sonik Blitz, which is a homebrew game for the Sega Master System, which I've built with GBDK 2020. If you'd like to check out the game, there will be a link in the description below where you can download the Master System ROM to have a play. Let me know if you find any issues with it. So I'll just show you now the game. So the idea of the game is to level the buildings before you can land. So if we press start to play, so the only buttons in the game are two and the right D-pad where you can speed along. So the idea is you create a path for Sonic to land, it's quite a simple game, but the idea is for me to show it off as one of the first, and I will be going into all of the source code for it shortly. So there are 10 levels in total. As the game progresses, he speeds up and the buildings are more taller. So a link in the description to that below. So now I will get into the code I'm going to be releasing. So the project I'll be releasing isn't totally the same as this. The idea is that I'll give you a code so you can kind of create your own games, not exact copies of mine. So there will be slight variations in the game Sonik Blitz and the project which I will be releasing. So I'll show you the other version of that which I'll be releasing. So this version here is the one I'll be providing the source code to. There are a few differences, purely graphical really. So if we open this one in Emulicious, you'll see our Viking character here, and things look a slightly bit different here. Other than that, the game is pretty much the same, except on my version I've added a few other little bits and pieces where when you clear the level, the character's plane flashes, and then each level on the Sonik Blitz game will have a different sky colour, and Sonic has a different plane each time as well. Those are the only real differences between them, just to set my version apart from the this one here, which is I consider to be OpenBlitz. So I will exit this now and we will jump into the source code, not in OpenBlitz but in the Sonik Blitz one. So to start with, I will go over. Wait, there seems to be some issues with this. Let's try that again. Right, so first off, I'm only going to go into the key things which I haven't discussed before really, and just some key points in the game code. So first off, when I was creating this game, I found some issues with the sprites. So the screen is set up as if it was going to be for a scrolling game, where I enabled the left hand margin, and for some reason when the sprites went out of the right hand margin and then come in the left hand, they were bunching up, which I hadn't coded for, so I assumed I'd put some sort of errors or bugs in there somewhere, but I couldn't find anything. And then it turned out it was because I was using the Messen emulator on Linux, which seems to cause that bug. So when I switched back to using Emulicious, the issues magically resolved. So that's something to be aware of. I have tested the Sonik Blitz game out on a MegaDrive as well, as the MegaDrive is backwards compatible with the Master System, and everything was fine. So hopefully, if you have an actual Master System, the ROM will run fine as well. So first off, I will dive into the game states here. So the project has a number of different game states here, and if you've seen some of my previous videos as well, you'll see that I also create other states called main states. So I would definitely advise that you're kind of happy with the simple state machine that I've implemented in the previous videos. I won't go into too much detail on these things here. The key things in here is these here. So these just load in the various graphics here. We got all of the tile graphics for the Fontset. So there's also some other things worth mentioning as well. Is the game has 2 fonts in it. So these are the various iterations I've gone over with testing things out and designing things. So there's also an 8x16 font set in there, and then there's also the numbers as well for the scores and the heads-up display characters. There's a number of things I haven't included in the actual game. So in this font set in here, there's a number of different like cloud characters which I didn't use in this version. Initially, if I open this up here, this was an early mock-up of how I wanted the levels to look. So first off, I was not using the left-hand margin, but as a result of that, without using the margins to hide the sprites, I put in a border either side, but then decided against having the border and instead used the left-hand margin, and also disable the sprites being shifted left by 8 pixels to allow the sprites to smoothly go out of one side of the screen and then come in the other. And I also played around with the sizes of the buildings as well. So if you imagine this is the tiles on screen, so we've got 32 by 24, which it kind of like a virtual tile map, if you like, where you can kind of plan out the levels, and these different colors represent the different sort of objects. This was going to be a border around the screen, and the plan was to have like a small fonts up here, but obviously I changed that later on. and this was to decide on the sizes of the buildings and where they would be laid out in the game. So here is the I didn't use these characters here for the crash. You'll see the crash when you have a look at it. In the end, this was the final character here. So that's the tiles for my Sonic character. You see I did like a few iterations of him without glasses there and some other sort of animation frames, which was kind of overkill. And then there's the life icon, which I created to sort of fit in. So getting on to the OpenBlitz version. So the differences are planar buildings and a different life icon. And you'll see the font set looks kind of cleaner and white actually, I think. And then there's our player character here. So I will leave links to the graphics for the game on my open source site as well, so you can customize those graphics and then use the tile creator as well. That'll have the image converter to turn those into tiles, so you can put them back in here. So yeah, the key things here are turning off that column, and then this is the main state loop here. So the game is pretty much either in the title screen or in the gameplay itself. Obviously you could put more things into this as you see fit in your game, depending on how complicated or not you want to make things. So now I will jump into the core game code itself. So the game has its own sort of local states where we kind of create like private functions, if you like, for the various sub-states that will be happening here. And then these are some hard-coded key variables for different things. You see here the maximum level is 10. These are timer values for some of the tick timers. So a new tick timer type which I implemented here is a 16-bit one for greater delays. The game doesn't really tax the Master System too much, so we kind of need to slow things down. So one thing I chose to do as well was to have this function here, the fire bullet command here. This is so that the player manager didn't need to know about the bomb manager, so I could kind of keep them separate. And the only kind of things which glue them all together really are being able to access the game manager, if you like. I keep getting tempted to call them classes, but obviously they're not classes. This is C, not C++. So there's a going back to the game code now. This is a new type here, a timer 16, so we can have longer delays in counting here. And then these are various functions which correspond to the different states. And then this private variable here, substate, is like is used in each of the state functions. So in the sort of substate functions, first off we always have the substate to 0. That allows us to have initialization code for each of the substates in the same function. which I will get into in a moment. So the two key main state functions are these here. So as this is a complete game, you can literally just use it as a blueprint for all of your sort of future games, if you like. I pretty much have this kind of format on all of the games that I code now, as I find it easiest to work with, whether it's on the Nintendo DS, the Wii, or the PC. It all it kind of scales across all of them nicely. So these are the two main functions here, which connect to the main loop, and then these are our various game states here. So the one of the first ones here is the game reset. So this one doesn't really use the substates at all. Whenever you level up or die or whatever in the game, to restart, it always comes back to this function here. And then to start each game, we would clear the screen, clear the sprites from the screen, and then we initialize everything to start in its starting locations. So this is the explosion manager function that initializes that. Then we initialize the player. We pass in the level to the player, as the level determines how fast the player will actually move. And then we have the bomb manager here, we initialize that. And then we initialize the level manager and pass in the level as well. It needs to know what the level is, so it can change the heights of the buildings to match the difficulty needed. And then we draw the roads. We then draw the text for the heads-up display, and then change the game state to get ready, which just displays our messages on screen. So this goes over the main sort of part of that. So we set the substate. If the substate equals 0 when it comes in here, then we initialize the get ready states that we need. So we have this blink timer variable here, which is just used in all of the various states which display a message on screen, like get ready or level clear, game over, or game won as well. That's a key one to have in as well. So if you can get to level 10, then you've won the game, and there is a state for that. So we literally just initialize the key parts for our substate, and then next time round we either blank out the message or we print it again. And then if the player presses the start button, then it skips the state. It's worth putting these in to each of the states, I believe, so the players can actually skip out of it. And then this just goes into the player died state, kind of exactly the same sort of thing really. Obviously they put like a, don't need that, put it caused just a delay really to separate the different states up so that things don't move into each other too quickly. So the key bits of the state here is, while this is happening, the explosion manager does its thing and changes the explosion tiles where the player was located. It then subtracts 1 from the lives variable. If it wraps around to 255, then we know that it's game over, and then we set that state there. Otherwise, we reset the game here, and then this is just hooks into the bullet manager here, so the player can call this function without having to know about the bullet manager. This is the key game code here, where we update the player, then draw him. Same with the bomb manager, and then same with the explosion manager there. As there are a number of explosion objects, we constantly need to call update, and then the player is responsible for changing its states depending on what's going on. So we need to keep checking to see what the player's state is. So if he crashes into a building, then we set that in the player manager, and if he lands, likewise. Obviously if he lands, then we can change the state to level clear. So these things here which I've commented out, so as you design games, you get to a point where it's like you've got the main part of the game working, but you might need to tweak certain things, which is why I've left this in so you can kind of see it in yours. So after I've got the key part of it working, you might need to check only the level clear state or the player died state. So sometimes you, rather than play the game all the way through each time, you just create a quick way to switch to that state, so you can see if it's working the way you expect it to work, which is exactly what I was doing here, using the op button to trigger a level clear allowed me to make sure that level clear was actually working, and each level was different than the last, and of course eventually the game would be won as well, and then I got to make sure that that state worked properly. And then the player die state allows you to check out how the player dies and also make sure the game over state works properly as well. So this here is the main sort of gameplay loop, if you like. We only redraw the score if the score has changed. And then in level clear we handle the sound effects here, which I haven't kind of haven't sort of displayed to you, but there is like sweeping sound effects here for level clear, game over, game won, etc. So using these sound commands here, well, first off, the sound channel off command here. So sound channel 3 is what is used for creating the explosion sounds, and I believe it's sound channel 1 is what I was using to create the engine sound as well. So you'll definitely have to look through how I was doing the different sounds. The reason why it took me so long to kind of get the game out really was I needed to wait until I covered the music and sound video, which I did. Otherwise the game kind of doesn't feel right without any sounds or music or whatever. There was another version of this game that I created before, but I couldn't kind of get to a point where I could put it out because I hadn't covered sound and music, and I felt that it needed that to kind of reach its full potential as such. So all we're doing here is we're using the lseed variable here, which is a global variable I use in most of the programs which I use to seed the random number generator normally. So in this case I'm repurposing it here to set the frequencies for all 3 tone channels, which are what we're using here. So this goes from low frequency to high frequency here. So this sets up the level clear state and turns the sound channels on with these frequencies here, and then next time it comes into this function it will come into this part here, which then decreases the value of lseed. If it goes past 1024, because it will loop round once it becomes less than 0, as it's an unsigned short. When it loops round, we know it's gone past 0. Although this here is really a debugging part of code I was using. This will never actually happen in the game because I've tweaked the seed decrement amounts here. So if you put the number more than 2, then this error gets thrown here. The idea is for that not to happen, otherwise the sound will loop around. And then as this is the level clear bit, this code here is the different code that I have in Sonik Blitz and not in OpenBlitz. I have an array of different colours for the plane, which I repurpose in this part here to cause a colour cycle. The plane colours for Sonic here, if I bring this back in, are in colours 6 and 7 here. 2 plain colours. So if I reload new colours into those 2 palette locations, then it will change the colour of the plane, which is what I do in the game here. And I also do a similar thing as well with the background colour as well, which is some simple things you can do to create variation in some of these games without increasing the amount of memory which is used. You can just play around with changing colours. Lots of the games at the time kind of did that, so it's worth making use of. And then we have 2 parts really in these the level clear state. We can either rely on the timer to tick down to 0, in which case we then change the state, or we can do it ourselves by pressing the 1 button here. Each time you complete a level, you gain an extra 50 points to your score. And then if your level is the max level, then the game state will change to 1. Otherwise, the game state is set to reset. And these parts here just hand over blinking level clear parts. Game 1 just displays you win and does the same sort of thing as level clear, except the this part here changes the main state to title screen once it ticks down, because obviously the game is done. It needs to go back to the title screen state. One of the key parts in here is when the game finishes, if the score is greater than the global variable in here. So I usually have like a global variable here with a score value. If you get this, then if you get past that, then that means you have the ability to put your name on like a high score table, or it will just say new high score with the score that you got. Just a nice little touch to add to your games, so it feels you've kind of bet the last person, or you've at least scored high enough to have a mention. So if you score higher than the global variable main state high score, then your score then becomes the main state high score. And then this is the game over parts here. Just displays the game over and does similar bits and pieces as the other states. That's pretty much all of the key parts in here. I'm not going to go over everything in total detail because lots of this stuff I've covered in previous videos. So some of the new parts, new functions that I've put in, which are worth mentioning. So we got the tick timer with a greater range, and then some new functions to print double height fonted lettering and numbers. So one of the key things with these variables, or these functions, sorry, is you first have to pass them where the tiles start, because the obviously the normal starting for the numbers in a character set are as per the ASCII numbers. So I think 0 usually starts at number 48, but as we have a load of tiles, that will not be the case. So if I come in here and we find some of these here, so this is the number one here. So as the 16 height numbers take 2 tiles, I've added in ptile2 pointer, so we can get the screen background addresses for the bottom and the top tiles, and then each time we need to draw one, we draw where are we here? So this, so we add the value between 0 and 9 each time to the number set start ID, which is for the tiles. So if I bring this back up and across, so each number takes 2 tiles there. Same with the Fontset here, but they're obviously tacked on at the end of the other tiles. So if I bring up my graphics define here a minute, you'll see this is the main start and tile count of the standard font set, and then using the graphics tile start and tile count variables pairs here, you can see we use the previous parts to tack on where these tiles will start. So these would be the numbers we need to pass when we draw a double height number or write a double height string. So if I come to the string one a minute, although it's not really too much different than the other. As I said before, we get starting locations for where we're going to print on the screen top and bottom tile locations, and then we get the number of the character in the string. If it's less than 65, then we need to print a 0, as we do not have any tiles less than 65. So again, we're going into the ASCII character set, where 65 is where the capital A is stored. So if the character is less than 65, then we will draw a blank. Otherwise, we get that character number, put it into T, and then we subtract 65 from that. So A would actually be 0. We then times the number by 2, as there are 2 tiles per each letter in the character set. We then add the font start to that variable, and then that allows us to draw that one character. So this will draw the top part of it, and then we increment the number of the tile and draw the bottom part. And then we need to skip the address to the next tile location. So that's the only difference there when drawing the double height characters, is they each take 2 characters, and then we need a background location for the top and also one for the bottom as well. That's all I kind of want to go into with those here. So let's jump into the player. So like other things, the player themselves have their own sort of states in them as well. Some of these are used, others are not using. So these are the functions and variables which can be seen externally. And then inside we have some private variables just for the player manager. So as I said, when the player starts, first off we divide the speed by 2 and then add 1 to it. So there is a limit to how fast the player can actually go. And then these here, these 2 variables here, are actually in game main. And that dictates where the player will be drawn each time the game starts. And then we set up our sprite manager. So this function here is a new one which takes assigned 16-bit number in for the horizontal position. That allows us to easily record where we are on the level. So if its horizontal position is less than 0, then we know that he's partly off the screen. As the character is made of 4 tiles, if he's minus 32, then obviously all of those tiles are off the screen. And if the horizontal position is greater than 255, then we know that he's past the right hand border. So this allows us to easily keep track of the sprite parts, which is another thing which is kind of handled here as well. The parts are clipped when they are outside of the 0 to 255 range, which is useful for a scrolling game as well. So some of these functions can be reused in other sort of projects later on, should you need them to be. So this just sets up the player to begin with. I've noticed that there is a I thought for a minute there I didn't initialize that, so that really could just have been I didn't use it after all. But yeah, that should have been set to that, which is exactly the same really anyway. And then during the player update here, we check to see if he's moved. We also check to see whether he's alive or not. If a state is not alive, then we do not read the controller or update the engine sound. So the engine sound is simply called every time the character is moved by briefly passing a low frequency sound there. Then increment the character's horizontal position. If he goes out of the screen, then we set him to be outside of the left hand border, so he loops around, and then increment the Y position by 8, so he moves down the screen. This is the part where we check to see whether he's collided with a building or not. If he collides with a building, then we call the kill command there, and then we set up some sound effects for the explosion. And then we tell the explosion manager to add tiles at key parts of the plane. So as you can see here, we first off get the horizontal position and then mask it so that it is aligned to 8 pixels, so it matches with screen tiles. And then this command here just draws, or rather spawns, explosion tiles at the key sort of parts. And then this part here just checks to see whether the player's position is at the landing position. If it is, then we set the state to player landed, so the game knows to level up. This is just a simple bit here in the PL kill where we set the state to crashed and then hide the sprite, and then set the moved to false. And then in the render command, we only draw the player if he's actually alive. And then the only tiles that we actually change are, if I bring the graphics back up again, so the only tiles we change is the end one here, where we just switch over for 2 prop positions here, which is what this does. If a frame, PL frame equals 1, then we set the tile to 8, otherwise we set the sprite tile to 6. And then this updates the position of the group of them. Bomb manager is fairly straightforward. There's only one bomb, and I slowed it down to 1. I did play around with different speeds, but the game would be obviously too easy if it moved any quicker than that. I'd have to put in loads of delays to slow things down. There's only one bomb character in it, and it just has an X, Y and a sprite ID, and we also have a variable here to record the sound frequency when the bomb drops. So the bomb kind of uses 2 sound channels potentially. We have one for the explosion sound if he hits a building, and then there's one for the whistling sound as it falls, where we use channel 2 for that one. And then if we hit a building, then we score 10 and kill the bomb. And we also call the explosion manager from here and spawn an explosion tile. This is some more debugging code that's in here still, to make sure the sound frequency stayed within the 0 to 1023 range. So when you fire a bomb, first off we check to see whether the bomb is already alive. If it is, then we take no action and just return false to say we've not spawned a new bomb. Next, we make sure that the plane isn't on the ground trying to fire the bomb. Then we align the bomb so it matches up horizontally to a tile, so it's aligned to 8 pixels. Then we set it to true. We then set the position to where we've been told to here by the bomb X and bomb Y positions. We then turn on the sound channels which are used for the bomb. When we kill the bomb, we just make sure we turn off sound channel 2 by setting its volume to 0. And then we put the bomb to alive as false, and then we hide the bomb sprite. And then this is fairly straightforward as well. Obviously this one here, we don't need to worry about the bomb being off the screen horizontally, so we can just use the normal sprite set position function, which takes in a byte for the X and Y positions, and that's the bomb manager. So in the explosion manager there are 8 of these. So if I bring back in one of the font sets here, so there's 4 explosion tiles here. So we have 4 frames for those, and that's the animation delay for them. And then we have a counter to make sure that the amount that are alive at any one time don't exceed the explosion maximum variable here, and then it has its own animation timer here. So a few things with this one here. One of the ways that we get the explosion effect with the sound is we have two variables here which control the volume of the channel 3, the white noise channel, and then we have another variable there which controls how long that value is held in place. So when we spawn a new explosion, we need to find one that's actually dead. So as there is an array of them, if the tile variable is greater than 0, then that indicates that that explosion is actually alive, as it will have a non-blank tile associated with it. So when we spawn them, they might not spawn necessarily in sequence. So we need to pick one from the list. So to do that, we iterate over the array of explosions. We find one that is not alive. We then set its tile to be inactive by putting it the explosion start tile. We then set its X and Y positions to the ones passed in, and then we draw that tile onto the screen. We then say that we've got a new explosion active, and then by setting the variable n to the maximum here, this takes us out of this loop here. So the way this works is if it doesn't pick one, then it will get to the end here and leave anyway. So it's not going to seize up if it can't find any. It just won't spawn any new ones. So the explosion add command here. So this doesn't actually take in tile positions. This takes in pixel positions as such, which is why we divide the pixel positions by 8 so that it aligns to tiles. Then we check to see if the explosion counter is less than or equal to the explosion max. If it is, then we don't spawn a new explosion, we literally just erase the tile that's there and return. So if you had a load of explosions going on at any one time, it would still erase the building part, but it wouldn't go through the whole animation of having an explosion occur. This calls the spawn the explosion there. So then we set up the volume step and the volume value here. So you can see here we set channel 3 on with a value of 6, which is one of the white noise sounds, which kinds of matches up to like an explosion as such. But to get the explosion effect, we tweak the volume over a period of time, which is why we use the volume value and the volume step. So we start off with 4 being the volume, so it's not totally off. And then each time the update function is called for the explosion manager, if there's an explosion that's alive, then it will update the volume over a period of time for the channel 3. Hopefully you can visualize that. If not, then you will when you actually play the game and you hear the explosions occurring. So these are some things I was tweaking around with here. This is the part which updates the tile for each explosion. So we always make sure that the sound is switched off at the end. So if there's a number of different explosions going on, then we don't want to turn off the explosion sound effect after just one of the explosions ends, just in case it's the wrong one. So every time an explosion is dropped, the volume and step variables will be reset. So only the most recent explosion will be triggering the volumes. So this here kind of tweaks around with the volume variable there, like so it divides the value by 4 each time, so it allows us to have like a greater amount of time that any volume is in place. And then this is to make sure that the volume variable never exceeds 15, which is the maximum volume variable that the SMS can take. If it did, then this command here will print on screen that it's occurred and allow us to debug that fact. Again, all these things, if you're not sure how they work, just go into the code, play around, and make sure you fully understand how they're doing what they're doing. So we'll now jump into the level manager. So the each location of the buildings is kind of hard coded in this array here. We've got the start horizontal positions for each building, and each has a set width as well, which is used to kind of create like a symmetrical looking layout. These are all handling, there's a tile sort of collision map that we create for the buildings, but I don't want it to cover the whole screen, only parts where the buildings will actually be. So if I go back to this picture here, you'll see here that the parts of the screen here will never have any building parts on. So to read these extra parts or set aside memory for them is obviously a waste. So I only create areas where there's likely to be tiles. So the height of each building segment can never be more than 18 tiles. So using that, we can create a collision map that is kind of matching the same size that we need. But as it's not the same size as a screen, we also create a bounding rectangle around where the buildings will be. So when we check each time with the bomb or the player plane, if they're not inside the collision rectangle, then there's no point going any further. We can just bin the collision check in there and then. So these just enable, these are just key bits here to creating the building parts. That's straightforward there, that draws the road. So initially there was going to be a top border and there was side borders. These are no longer used, but they are still in here. Or rather the side borders one is. I didn't end up drawing a top one in the end, so I should probably get rid of that to clean things up. So the key things we need from here is get the tile and the collision map. So not really used that much in this game, but for other games it could be more useful really. If you had a load of different tiles that make up the level, then you might want to check what actual tile is at the location where you are. For example, if you had like a platformer with like springs, spikes, all that sort of stuff, then colliding with a tile on the collision map, you would definitely want to know the actual type. So the number here, the collision map, the numbers that it returns don't actually represent the graphic tiles. They are whatever you want them to be, basically. They're IDs in the collision map which separate one collision object type from another. So this command here will clear our collision map. And then obviously the two key ones we use throughout the game is the position that we're passing in, colliding with a building, and the initialize level function. So there are various things that go on here in the level manager. The buildings are created randomly, but we obviously need to record the key variable ranges for these buildings. So if I sort of start at the top here, so these are sort of key variables in here. This just gets the start of our collision map and then sets each of the locations to 0. This will just check to make sure, first off we'll try and make sure that the tile position is actually within the collision map range. If it is, then we return the tile at the correct location in the collision map. Otherwise we return 255, which is just a number which I decided would be to indicate that there's an error, which is obviously useful for when you're kind of starting off the game debugging things. This private command is just used to set a tile. So you'll see we've got the global variable here, collision map width. And then obviously if it's outside of that, then we throw an error there. Again, this is for us to debug really. The actual players would obviously not need to know anything about any of these things. Drawing a road is straightforward. Oh yeah, so one of the things I haven't covered here is this command here. This takes in an attribute byte as well. So as you should know, the Master System tiles take additional attributes in, so they can be mirrored horizontally, vertically. In this case, they take a greater priority than the sprite. This is the priority flag. So by adding that in, it means the road will obscure the player's plane. So it looks like if parts of the plane overlap the road, that the road is obviously on top. And in the other version of this, I did exactly the same here with the priority flag. So in each of the draw commands for the Master System, it actually takes in use 16 for the tile. So this is why I've times the top priority byte by 256 here, shifting it across. The lower byte of the 16-bit number is always the tile ID, and then the topper part, or the the higher byte, if you like, is always the priority flags. So to get into the buildings part here, I'll need to come to the initialize level part first, because this jumps around a bit. So each time there's a level here, we use the sky palette array here to set the sky color. So we're just changing color 0 to affect that. But one thing with the game is the player's life icon. The tiles actually use the sprite palette for that. So the tiles themselves, they can use any of the 32 colours in the total palette range on the Master System. But because of that, it means I have to change the sprites 0 colour to the sky as well. Otherwise, the player life icon would have a different background colour to everything else. And then this gets the palette starting location for the player playing. If you play the Sonik Blitz game, you'll see that each level the Sonic's plane is a different colour. So in here we first off clear the level collision map. And then one thing we do here is we want the level ID after this point to always be a multiple of 2, as the level ID is used for creating the varying heights of the buildings. So these bits here just change the colour of Sonic's plane. This initializes round each time, using the LSEED value, which constantly changes throughout the game. Then we call this command here to draw the buildings, and then we create a bounding rectangle for the collision map. I'm not actually, I wasn't sure if I was using it or not actually, but that just verifies that I am. So the level manager draw buildings takes in 2 variables there, or true or false. So it will create the collision map for us as well. The reason why it takes 2 in here is because I use it for the title screen. So obviously if we're drawing it for the title screen, we obviously don't need the collision map. And then all we do here is iterate over our array at the top here, taking the widths and the starting X positions. We then plug those into our local variables there, and then we call the draw building command with the starting position XYs, the width of it, the height. So this is what changes the heights of the buildings here. And this takes in a type. So there are two types. It just, if I bring up the building again, you'll see there's one colour and then another colour. So there are two types. Obviously in your own version you could add more different building types in there to mix it up a bit more if you wanted. So the building parts, they have a standard roof. So these are a few variables to take in the different parts we need for constructing our buildings. So we draw them from the ground up pretty much, or rather we work out from the ground up. So the end Y is literally the tile location above the road minus the height, which will obviously be our sort of starting position. And then we call the various fill commands to put in the tile parts that we want. This is the sort of like body of the building, if you like. So if it's type 0, then we will draw a building out with the left, middle and right parts of the building. And then if it's type 1, then we'll use the other tiles to do that. Collision map looks a bit more in depth, but it's kind of just taking the same sort of things really. The only difference is we need to make sure that the positions are slightly different, because obviously we need these to be inside of the tile map. So this works out the sort of like starting position of the buildings, or the building that's passed in, and then just creates a block that mirrors that building's size in the collision map. All we're doing in this collision map is setting that location to 1 if there's an object to hit. And that's pretty much it for the initialization. Definitely worth having to play around with if you're not sure what's going on there. Tweaking all of these. Collision maps are definitely needed on the likes of the Master System and the NES really. There are commands on the Game Boy to actually read the video memory directly, but according to GBDK it's best not to do that. But depending on the sort of complexity of the game, it probably, well, it doesn't actually make any difference on the Game Boy, to be honest. So the hit building collision function here, all we're doing is taking in the pixel position here that we passed, dividing it by 8, storing it in the X and Y positions here. If it's greater than 23, then we know that it's off the screen, so we return true to say that, yeah, you would have hit the road. Otherwise, we first check to make sure that the position here at X and Y is inside the collision rectangle. If it is, then we go through the process of checking the collision map. All we do is use get tile, so we get the X position there, and then what we have to do here is subtract from the Y position the collision map start position. So what that is where the collision map would be drawn if it was physically drawn on the screen. So the collision map can only be 18 tiles high. So we need to subtract the difference to make sure that these tiles fit inside the collision map. If there is a collision object there, then we first clear that tile on the screen, although it's not really needed because the explosion manager does that, but it's there anyway. We then clear, this is the key thing here, you need to make sure that you clear that location next on the collision map, otherwise you will keep colliding with invisible objects, which is obviously something that you don't want. So that's it for the level manager there. Let's see, what else have I kind of got. I think that's everything here that is majorly different. Definitely look through the code. Links in the description, and I will also provide links to the graphics as well. This video has actually gone on for quite a while, which I thought it would, so I will end it there. Let me know if you find any bugs, or you've got any questions about the code, and I will catch you in the next video.